Interstellar objects are supposed to pass through our solar system and disappear. They enter from the darkness between stars. They move fast. They follow gravity. And then, just as suddenly as they arrived, they leave. But this one did something that made scientists look twice. Its path did not seem to behave exactly the way a simple object should. At first, the difference was small, a shift, a deviation, a motion that could be explained in several ordinary ways. But the more astronomers studied it, the harder one question became to ignore. What is changing the path of this interstellar visitor? For most of human history, we thought our solar system was almost closed. The sun, the planets, the moons, the asteroids, and the comets. A cosmic neighborhood moving through the Milky Way, mostly separate from the stars around it. But then astronomers discovered something that changed that picture. Objects from other star systems can enter our solar system. They can pass through the region of the planets. They can move around the sun. They can cross our skies. And then they can vanish back into interstellar space. They are not from here. They are visitors, fragments from other worlds, debris from other stars, ancient bodies thrown out of their home systems millions or even billions of years ago. And when one of them enters our solar system, scientists have only a brief window to study it. There is no second chance. It is moving too fast. It is too far away. It is often too small or too dark to see clearly. By the time we understand what we are looking at, it may already be leaving. That is why any strange behavior matters. A normal comet can change its path slightly because gas and dust escape from its surface, acting almost like tiny thrusters. An asteroid usually follows gravity more cleanly. But an interstellar object is different. We do not know where it formed. We do not know what it is made of. We do not know what happened to it before it entered our solar system. So when its path appears to shift in a way that does not match simple expectations, the mystery becomes much larger. Is it releasing gas we cannot easily see? Is sunlight affecting it in an unusual way? Is it shaped strangely? Is it breaking apart? Or is there something about its nature that we still do not understand? The stakes are not only about one object. They are about what these visitors can teach us. Because an interstellar object is a sample from another star system, a piece of somewhere else, a messenger from a place no spacecraft has ever visited. If we can understand it, we learn not only about our solar system, but about the systems beyond it. But if we cannot explain its motion, then we are forced to admit something uncomfortable. Even when the universe sends something directly through our neighborhood, we may still not know how to read it. And this object, moving silently through the inner solar system, may be telling us that the space between stars is carrying stranger things than we expected. To understand why this object's path matters, we have to understand what an interstellar object really is. Most objects in our solar system belong to the sun. The planets orbit the sun. The asteroids orbit the sun. Most comets, even the distant ones, are still tied to the sun by gravity. They may travel far. They may disappear into the dark for thousands of years. But eventually, many of them return. They are part of the family. An interstellar object is different. It is not born here. It does not belong to the sun in the same way. It comes from outside, from the space between stars, carrying a history that began somewhere else. Maybe it formed around another Sunday. Maybe it was thrown out during the birth of a planetary system. Maybe it once orbited a world we will never see. Maybe it drifted alone through the Milky Way for millions of years before crossing our path. That is what makes these objects so valuable. They are not just rocks. They are messengers, physical pieces of another system delivered directly into our cosmic neighborhood. But they are also extremely difficult to study. By the time astronomers discover them, they are often already moving fast through the solar system. Unlike ordinary comets that may return again and again, an interstellar visitor may appear once and then vanish forever. There's no long mission plan, no perfect second chance, and no easy way to send a spacecraft after it. Scientists have to gather as much information as they can before the object fades into the dark. Its brightness, its color, its shape if possible, its speed, its direction, its changing position against the background stars, and most importantly, its path. Because an object's path is like its fingerprint, it tells scientists whether the object belongs to the solar system or came from beyond it. It reveals how strongly the sun is pulling on it, It shows whether the object is behaving like a simple body under gravity or whether something else is affecting its motion. For a normal asteroid, the path should be predictable. Gravity dominates. The sun pulls. The planets tug. The object follows the curve that physics demands. For a comet, things can be more complicated. As a comet approaches the sun, ice on its surface can heat up and turn into gas. That escaping gas can push the comet slightly, like a weak natural rocket. The force is small, but over time it can change the path. That is called non-gravitational acceleration. It sounds technical, but the idea is simple. Something besides gravity is nudging the object. Most of the time, this is not mysterious. Comets do it. They vent gas. They shed dust. They grow tails. They behave like dirty snowballs, warming under sunlight. But an interstellar object can make that explanation much harder, because we do not always know what it is made of. If it is a comet, where is the tail? If it is venting gas, why is the gas difficult to see? If sunlight is pushing it, why does the motion look stronger than expected? If it is shaped strangely, how does that shape affect the way it moves? These are not casual questions. They matter because an interstellar object is not just another rock passing by. It is a clue from another star system. And if we misunderstand how it moves, then we may misunderstand what it is. At first, the object appeared to follow a path shaped by the sun's gravity. That was expected. Anything entering the solar system has to respond to the sun. The sun is the dominant mass here. Its gravity bends the path of anything that comes close enough.